We'll start with learning. What is learning? Learning is a mechanism by which an artificial intelligence model learns and acts on its environments. So, learning is essential for unknown environments, that is, where there is a probability of an event happening and the model is unaware of it. So, that scenario is termed as unknown environment. So, for example, when designer lacks omniscience, it is termed as an unknown environment as well because the designer is unsure about which environment the model will be deployed on. Similarly, learning is useful as a system construction method to expose the agent to reality rather than trying to write it down. So, whenever there is an elaborate environment and we cannot write it down fully, so we need to apply learning so that the model is aware of its environment. Finally, learning modifies the agent's decision mechanism to improve performance. So, by learning only, the agent learns its environment and is able to build on its decision mechanisms to improve its performance. So, in this slide, we shall see a learning implementation by an artificial intelligence agent. So, this is our model and the agent is here, environment is here. So what the slide says is the agent learns from its environment via sensors, gets the data of environment from sensors and passes to both performance element and critic. So the performance element basically provides output to the effectors, but before that it also processes changes from the learning element here. So what are the changes? So the critic first takes the sensor data and along with performance standard it passes it to the learning element as a form of feedback. So this feedback is taken by agent from the learning element node and it outputs learning goals, what the agent needs to learn at the current situation. Next, this problem generator generates a problem based on the new learning goals on and it passes to the performance element after doing some experiments here. So these experiments will result in a knowledge that is again passed to the learning element, and if any changes are required, these are again passed to the performance element, and finally it gives the output to the effectors, which is passed on to the environment. Hope this is clear. So basically what is happening is data is get obtained from the sensors from the environment and pass on to both critic and performance element, and after the knowledge is applied to the knowledge base here, uh, related output is obtained from the performance element after changes are made and passed to the effectors. Now we shall see what is learning from examples. When the agent performs an action, a specific reward is given or not given sometimes in order to better the action of the agent. An intelligent agent learns from the following components: a direct mapping from the current state of the AI model or current percepts to actions. Second is a means to infer relevant properties of the world from the percept sequence, that is querying the knowledge base. We have seen this earlier. When we are given a percept sequence, there should be a means to infer relevant properties of the world from it by querying the knowledge base. Third is information about the way of the world evolves and about the results of possible actions taken by the agent or a learning mechanism of the agent. So third one is the most important, which is in the current context of my speech, that is learning mechanism of the agent. So fourth one is utility information indicating the desirability of world states. So this holds what goals, if any, achieved are favorable. So utility information, as I have told, what is utility? It is based on uh, giving appropriate goals to the agent, that is required goals out of all the goals achieved. So fifth one is action value information indicating the desirability of actions. So whatever actions the agent performs, it will be judged by the person who is implementing that agent and give the desirable uh, feedback on those actions. So last one is goals that describe the classes of states whose achievement maximizes the agent's utility. So it is nothing but the agent should get the best goal that maximizes the agent's utility. So basically, what are types of feedback? In supervised learning, we give correct answers for each percept. So since we are supervising the full learning methodology of the agent, we give correct answers for each percept. So the agent knows what output will be the correct one in each case. In unsupervised learning, correct answers are not given against all the percepts. So this is basically without any answers, the agent has to learn. And in reinforcement learning, occasional rewards are given to the agent based on its actions. So the agent can know which actions to perform in the particular scenario. So in this slide, we shall learn about supervised, unsupervised, and reinforcement learning scenarios. So in supervised learning, what happens is machine learns explicitly and data is clearly defined and its output is also given clearly in each case, and direct feedback is given, that is for every action the feedback is given for the agent. And what it is used is supervised learning is mostly used in predicting outcomes or future, and it basically resolves classification and regression problems. Hope this is clear. And in unsupervised learning, machine understands the data or identifies patterns or structures. So basically, we don't give any feedback in this case because it has to learn on its own. So it identifies patterns or structures in the data. Uh, Basically, it does not predict find anything specific, and evaluation is qualitative or indirect. So we just judge the final output of the model based on qualitative or indirect evaluation. So what is reinforcement learning now? It is an approach to AI and it is reward based learning. So we give some rewards to the model if it is performing some desirable actions, and the model accordingly learns from positive and negative reinforcement, that is positive and negative rewards. So it learns from that, and machine learns how to act in a certain environment. So by this technology, the machine learns to connect with its environment better, and it the final aim is to maximize rewards. So machine tries to maximize its positive rewards. So in that way, it will learn its environment and act accordingly. So these are the steps in supervised learning. Initially, take the entire set of questions that you know the answer to, and corresponding data elements or attributes against each question are also collected. So this is basically taking the entire data and along with that attributes of output uh, for which data is given. Then we feed the data along with the output against that data to the machine to make it learn the pattern or train the model. So as I have discussed earlier as well, what happens is we feed the data along with the output against the data to the machine to make it learn the pattern or train the model. So basically it is learning the patterns and how the data is matching with the output. So we give the data and output both to the machine and it learns the pattern. Later on, take an example of prediction which you are not aware of answer and the model predicts the answer for you for that instance. So what it says is based on that pattern, later on we give some input to the model and it gives us the answer or predicts the answer for us. Since we don't know the output for that, so the machine will give the output based on that pattern on which it was trained for. So the examples of supervised learning are given a set of browsing habits and human mood. We can predict what he she wants to listen watch at that moment. So you must have seen this in your browsing music app and streaming apps. When we are listening to some kind of music, there will be a recommendation based on that type of musical tracks mood or what we are watching at the moment. So another example will be given a set of data points of relevant health attributes for a set of patients and whether or not they have diabetes. We can predict whether a new patient has diabetes or not given those set of data points for that new patient. So this is more important in Medicare industry. So if you are given a set of data regarding health attributes of a set of patients that have or don't have diabetes, the we can train the machine on those attributes or pattern with that set of output of yes or no against diabetes. So then the machine can predict whether a new patient has diabetes or not given those set of data points for that new patient. So if we give those set of data points for that new patient alone, it will take the pattern classification along with that trained data and predict whether that new patient has diabetes or not. Next is unsupervised learning. So when the corresponding output against the input data set to the model of the learning agent is not known for all the instances, it is known as unsupervised learning. Rather, when we know the output against all the input, it will be supervised. But if we don't know the output against all the inputs, it will be unsupervised learning. So this type of learning is beneficial, for example, when we want to make cluster or groups from a set of data points which are input to the model so that they can be differentiated based on those groups. That is, we make different types of groups based on the patterns of the data. So one type of pattern of data will be in one group and other type of pattern data will be in other group. So for example, given a set of data points that have attributes of shopping done by male and female youth, we can attempt to divide the users based on gender. So this is clear. We have a set of data points of shopping done by different types of people, both male and female. So we can attempt to divide them based on gender. Finally, we move to reinforcement learning. Reinforcement learning is used to make a sequence of decisions. The agent learns to achieve a goal in a certain potential complex environment. In reinforcement learning, an artificial intelligence faces a game-like situation. Its goal is to maximize the total reward which is given when the agent performs an action in that environment. So this is mostly used in robotics and other such scenarios like self-driving cars and so on, in which the goal is to maximize the total reward which is given when the agent performs an action in that environment. So suppose there is a self-driving car and we want to ensure that it runs in a best way. So that for each action it will be given an reward. So if it steers well, it will be given a good reward. So from next time if a situation comes, it will steer in that way. So it knows that this action will give me the best reward. So that is reinforcement learning. That is, agent learns how to achieve a goal in complex environment with feedback, occasional feedback given to it based on its actions. Hope this is clear. Now, what is inductive learning? Simplest form is a highly simplified model of real learning which helps to ignore prior knowledge and assume examples are given. So, it is inductive learning is basically learning by example, and it is bottom to top learning. Basically, when a problem is given, we find a hypothesis such that this hypothesis is equal to that problem, equivalent to that problem. So it is given in the second paragraph. Learn a function from the following examples. An example is a pair x or comma fx where f is the target function. Problem is a find a hypothesis h such that h is equivalent to f. Construct adjust h to degree with f on a training set, and h is consistent with f. It agrees on all the examples. So problem is to find a hypothesis h such that h is true and h is equivalent to f. So we are starting with x, and we have f is the target function. So target function has to be true, and we find a hypothesis h such that h is equivalent to f, which implies that f is true, and we construct or adjust h to agree with f on a training set. So by starting with a hypothesis, we move on to more hypothesis such that h new hypothesis h is agreeing with f on the training set, and h is consistent. That hypothesis is consistent with f if it agrees on all examples. So that is how inductive learning is applied. Next, we move on to a more elaborate concept of learning, that is learning decision trees. A decision tree is a decision support tool that uses a tree-like model of decisions and their possible consequences, including chance, event outcomes, resource cost, and utility. It is one way to display an algorithm that only contains conditional control statements. So the decision tree is a tool that has a binary tree-like classification, so which has models including chance, event outcomes, resource cost, and utility. So basically, it is one way to display an algorithm that only contains conditional control statements, which implies that every branch of the decision tree is done on uh, conditional control statements, which may be either yes, no, or maybe a conditional statement like color is equal to yellow, or so on. So decision trees are commonly used in operations research, specifically in decision analysis, to help identify a strategy most likely to reach a goal, but are also a popular tool in machine learning. So basically, mostly they are used in operations research where they help to identify a strategy which is most helpful to reach a goal for their operations research problem, and otherwise it is a popular tool in machine learning. We'll see next the details of how decision trees work. Expressiveness of decision trees is discussed in this slide. So decision trees can express any function of the input attributes. So basically, they all decision trees end in leaf nodes. So for Boolean functions, it is shown here P XOR Q. It is the truth table on the left side and the decision tree is on the right side. So basically, it is a binary classification tool for this Boolean function true or false. Basically, outputs will be. So trivially, there is a consistent decision tree for any training set with one part to leave. For each example, unless f is on non-deterministic in X, it probably won't generalize to new examples. Prefer to find more compact decision trees is the most required feature for when applying decision trees. So we need to find the minimal decision trees when we apply any decision trees. That is our goal. And basically, any uh, consistent decision tree can be made for a training set unless that the function implied by that training set is non-deterministic in X. Hope this is clear. Now we move on to the concept of Gini impurity. So what is Gini impurity? It is a measure of error of classifying a decision tree, and it can be calculated at each classification step. Suppose we have a root node here of decision tree where we have all the samples or features of the input set. So based on some condition C, say suppose we have condition C, and based on condition to be become true, we classify this as few set of features here, and other set of features will come here based on this condition being false. So suppose we go on classifying like this. So Gini impurity will be calculated at this step of classification. So it will be calculated as total number of features here coming here, and based on some formula as shown here, and total number of features coming here. Suppose 3 will come here, 3 features. So on that Gini impurity is calculated, and the lower the Gini impurity, the better the classification. So suppose we have another, suppose we have this root node as here, and this is the set of full sample spaces, and we have a condition D, other condition. So we are first classifying based on condition D becoming true, and condition D becoming false here will go in this. So I'll explain the formula in detail later. Let us first understand what is this used for. Suppose we get two feature sets here and two features here, three features here in fact. So which one is the better classification is decided by this Gini impurity value. So the lower this Gini impurity value for this classification, that condition will be used to initially divide the decision tree. So if we are taking dividing the decision tree based on condition D, the Gini impurity G value should be lower than this of that of dividing by C. So the lowest Gini impurity value is taking at each step, and these all calculations need not be done by us. We just pass the classification parameter to the our model, and it will do it for ourselves. But I am telling you how it is done, so that you understand how it is done actually by the model. So what is PI? PI is the probability of randomly picking an element of class I. So class I is like, that is this feature. So randomly picking this feature will be number of I mean the probability of this feature will be this feature happening, that is like suppose E by total number of features, that is 3, E by 3. So something like this. So we'll calculate this formula base from summation from 1 to 3 for all this, and this will be for this 2 variable here, 2 condition, and similarly we'll continue for this, and we'll take a weighted average for both. This will give us the final Gini impurity value. So that has to be lower than this C value in order to be taken into account for classification at this step. So suppose at this step here we want to further classify based on some conditions, say E. So we'll take again the same formula Gini impurity and move on to the classification. But again, these all need not be done by us. The model will do it mathematically on itself. We just need to provide it the feature values. Hope this is clear. So when training a decision tree, the best split is chosen by maximizing the Gini gain, which is calculated by subtracting the weighted impurities of the branches from the original impurity. So Gini gain is different from Gini impurity. Gini gain is a difference of Gini impurity of branches from the Gini impurity of parent node. So suppose we had the node here of the original training set as having Gini impurity say V, and we divided it based on say condition D, which was having lower Gini impurity, D true and D false again. So it will give us a feature set here and a feature set here, and suppose the Gini impurity at this set is B. So we'll simply say gain is V minus B. So basically the gain should be higher and Gini impurity should be lower. So that will maximize our decision tree effectiveness. So now we move on to information gain and entropy. Entropy is a new word here, and information gain can be used in reference to both entropy and Gini impurity. So information gain is the improvement of purity before and after splitting. Basically, it is Gini gain in case of Gini impurity when we are calculating Gini impurity in our model. So entropy, what is entropy? Entropy is the probabilistic measure of uncertainty. Given a k class subset and f subscript k, where fk is 0 and between 0 and 1, that is a probability event denoted as the fraction of data from class k, where k may be from 1 to capital K. The entropy of the data set is defined as follows. Entropy is equal to minus of summation k is equal to 1 to capital K f of k into log 2 fk. So basically, if we are given a k class subset and capital K class subset, I mean, and we have f of k as the probability of uh, that feature or class happening in that division, and then entropy will be minus of summation k is equal to 1 to k, that is for all the classes at that division, fk into log 2 fk. So that will be clear once I move on to the next slide. So now I'll discuss how entropy is calculated. Suppose this is our main node which contains all the features, and it is divided into based on some condition set of feature space uh, A and B. So our entropy is calculated as uh, summation I is equal to 1 to 2, because there are two feature sets. So f of what is basically happening is, if we cancel this out, f of A will be probability of event A and f of B will be probability of event B. So both will be taken, and along with log of FA and here log of FB, and we'll put a minus sign, so that will be entropy. So in this case we calculate the information gain as this formula, and where HT by A is this. So basically, if we go deeper into the maths involved, what is happening is the lower the entropy is, the better the division and higher the information gain. And higher information gain or lower entropy indicate better splitting. So basically, at each step, we need to calculate the information gain, and this is also done automatically by our algorithm. We do not need to go in deeper into the maths involved. But what's happening is, uh, for each feature here, this information gain is calculated for A and B. Suppose both of them, this is calculated. So HT is nothing but this entropy here. For FA, it will be HA, the entropy for A, minus HT upon A. So on upon A formula is given here. What it is it excludes the entropy for A and calculates the other values. A means for other features excluding A. So for B it will calculate, it will be total, that is two features, and into H of each of the other features here, that is H of B into SA of B, so that is probability of B. So in that way it goes on calculating HT by A, and it substitutes here, and finally we get the information gain. Next we move on to hypothesis basis. How many distinct decision trees with n Boolean attributes? N is the number of Boolean functions, M is the number of distinct truth tables. What is the number of distinct truth tables with 2 to power n rows? It will be 2 to power 2 to power n. For example, with 6 Boolean attributes, there are so many trees here. So basically, the more the n, the higher the number of decision trees can be made, whereas the number of Boolean functions or features or attributes. So how many purely conjunctive hypotheses? Example, hungry and not of rain. Each attribute can be positive and negative, or output can be 3-point distinct conjunctive hypothesis. So the more expressive hypothesis space increases chances that target function can be expressed, and increases number of hypotheses consistent with training set may get worse predictions. So this is the decision tree learning algorithm. So the aim is to find a small tree consistent with the training examples. Idea is to recursively choose most significant attribute as root of the subtree. So the most significant attribute will be that one with the highest information gain. So basically from here to here it is just testing sample and other null values, and otherwise we take the best as the choose attribute which is the best attribute out of that feature set to be taken as the divider node, and make a tree out of that uh, node having that being as the root node, and for each value of leaf of that tree do the same algorithm. Examples will be elements of example with best is equal to vi, and subtree will be DTL again because recursively calling it with examples attributes is equal to best and mode examples. So and we add this branch to tree with label vi and subtree tree, and then we return the tree. So basically that node is returned as a tree. Choosing attribute idea is a good attribute splits the examples into subsets that are ideally all positive or all negative. So suppose we take decision condition D that I have discussed earlier and divide in the main feature set into two sets, then the left set will be ideally all positive or all negative, and the right side will be similarly all negative or all positive. Now we move on to passive learning versus active learning. What is passive learning? Passive learning, the agent learns the utilities by observing the real world activities but does not act. So action is missing in passive learning, while in active learning, the agent learns by observing the real world activities and also acts accordingly. So in active learning, action is also involved.